Okay, so today on the bench we have a ECM from Subaru, part number 22611AM86A. This particular one is from Subaru Outback LL Bean edition. It's 6-cylinder. Those boards are notorious for misfire on the 6-cylinder, and the root cause of it is the cold solder under that chip. The chip in question is SC900724. I couldn't find any data sheet for it, so I don't really know what it is, but I assume it's some kind of a MOSFET array. Basically, it controls the signal for the fuel injector on the 6-cylinder and probably a few others. It also has something to do with the immobilizer, and the only reason I know that is because when I messed up soldering on it, the car wouldn't start. And the idea now is to, because one solution that you can find on some forums is to put the board in the oven, and that fixes it for about a week, maybe 2 weeks. The other solution is what I did, just blow some hot air on it of 350 Cs, wait for the solder to molten, and that also helps for about a week. So now we're gonna fix it properly, meaning we're gonna take off the chip, clean the pots from the lead-free solder. We're gonna put new nice leaded solder on it, and hopefully re-bowl the chip, but this one doesn't really need re-bowling, and I really doubt I have a proper stencil for it. So most likely we're not gonna be re-bowling it, but chips this small, they don't necessarily need re-bowling. Okay, everything synchronized. Okay, so this is our guy. I should be able to hold it with my tweezers. Now, there. First, I'm gonna set it to 100 degrees Celsius at pretty much highest airflow, and just preheat the board a bit. Now here's the trick. I don't know if you can see it. These capacitors, electrolytic capacitors, let me show it to you under the microscope. These big fellas, when exposed to too much heat, they explode. So actually, let's get some light here. Okay, so actually I'm actually not gonna take any chances. I'm gonna put some Captain tape on it, if I find it here. There you go. Okay, a little bit of Captain tape goes a long way. And a knife. This chip luckily is not surrounded by a lot of discrete components, so it's not gonna be that hard. Just let's stay on the safe side. There. Now it's covered. I could surround everything around it with Captain tape to be safe, but if I knock off this little capacitor here, that's not a big deal. This one also, so it's like just 2, maybe 3 components around it that I can potentially dislodge. We already have a lot of mess here, and we haven't even started. Okay, let's get the nice view on it. Let's see, I'm gonna hold it with right hand. No, actually it'll be better if I hold it with my left hand. Probably. We'll see how it goes. First, let's preheat it. The preheating can be done in the oven, but I never trust the oven solutions. I always feel like something's gonna melt, and I don't need to preheat the entire board. I just need to preheat the area around the board. The reasoning, let's check out the components underneath. Fairly big components. I wouldn't expect anything to fall off there. I'm actually doing it without looking in the microscope. A little bit here, a little bit here. I'm just using the 100C on the temperature, so it just preheats the board. No soldering yet. It's barely enough to liquefy the flux. There's some old flux on it. Yeah, you can see it bubbling now. Now let's up the temperature to, this is lead-free solder, so I'm gonna go as high as 350. That should be enough, but we'll see. The worst case scenario, since I don't have a bent nozzle, the worst case scenario is if I don't heat it up enough and I pull the chip too early, I'll rip off the pads, and the pads are tiny here, so I definitely don't want to do that. Got plenty of smoke coming. You see bubbling, but that's most likely, let's touch it a bit. Okay, I think that was too early. Okay, chip is off. Okay, now let's see if I ripped off any pads. I did not. And actually, you can see it, on this side, they look pretty. On this side, not too much. The trace in question is this one over here. So this is pin number 1, so this is like second to last if they just go around, and most likely that's how they go. Again, I can find a data sheet for this chip, so I'm not sure what I'm dealing with, but you can see that this doesn't look good. Okay, so step 1, we're gonna get the soldering wick, some flux. It's important to use good flux. Are you kidding me? Okay, I lost the image from the other camera. So looks like all you're gonna see is what you have under microscope, because of course Windows decided that it needs to update now. I don't care what you're doing, I gotta update. I like everything against me today. Okay. The recording didn't stop. Let's hope I'm not gonna lose the image from the microscope. Let me see if I can restore the image on my main camera. Okay, I guess Windows updated and now it needs a long time to start. So what are you gonna do? A microscope image will suffice in this case. Now, soldering iron. The tip I'm gonna use is pretty big. It's a lot bigger than needed, but I want a good heat transfer, so I don't rip any of the pads off. And let's give it 290 degrees. That should be enough. If it's not gonna be going well, then I'm gonna blow some more hot air on it, or maybe I'll put some nice leaded solder on it. And that will speed up the cleaning process, or at least make it easier without risking damaging the pads, because this would be another nightmare. You can't really see it under the microscope, or it's not very clear under the microscope how small this is, but it's pretty small. I do not want to have to restore those pads. Okay, now the wick. Now let's move this chip away from here. Oh, and it gets stuck. Okay. We need to clean the chip as well. Not only the... Okay, where are you? Here you are. Alright. Okay, and I think I need more flux. Yeah, it's a lot of flux. It's probably a bit too much, but... Okay, and now, without any pressure, just let the temperature do its job. And it looks like my temperature's not high enough. It cut the wire. So I'm gonna go up to 325. No, it's still holding it. You need to be very gentle with this, because it just takes a second to rip off the pad. Don't be tempted to pull it before it's ready, before the temperature's high enough. Okay, still holding it, but I could use some hot air, but that will require me to have a third hand, which I don't have yet. So I'm gonna go to 342. The temperature. Let it heat up. That's why I use oversized tip. Come on. Let go, let go. Okay. Alright. Now let's clean the tip. Got the wick. And again. More flux. The point of this is to get rid of all that lead-free solder here. Without breaking any of the pads. No pressure, just gently move over it. Okay, this is nice and clean. There. And the battery on my laptop just went dead. 6%. This guy. Oh. Oh. There. Clean the tip. Cut the wick. Rinse and repeat. Just this one. No. Oh. Now, there. Okay, that looks almost perfect. It doesn't have to look perfect. The point is to get the most lead-free solder off. It doesn't have to be perfectly clean, because the lead-free solder will mix with the leaded solder. This one a bit. Okay. And a little more. You caught me now. So don't fight with it. Just put some more flux and heat it again, and it should let go. No, it doesn't want to let go. Okay. There. There. Okay. Alright. Oh, this one. I don't like this one. One more. One more. I don't like that one pot over there. This one over here. Over here. Okay. And this one. Still. Okay, that looks good. Okay. The iron goes there, and now how hot is it? It's pretty hot. But while it's hot, we can clean it, because the flux is going to be nice and soft. It's still smoking. And there you go. Let's see. There's a lot of mess around it. Some cheap flux. It's very important to use expensive flux. Don't cheap out on flux, because that, if you ever had a feeling that it looks a lot easier when people do it on YouTube, and the solder doesn't quite flow the same, don't buy better soldering iron. First buy better flux and solder and see the difference. I'm using pretty much the cheapest tools, but not the flux and solder. Those I buy expensive. Okay, that is nice and clean. All right. All right, so this part is done. Next part is to see what the chip looks like. On the other side, of course. There. Okay, this one's a little bit more tricky because we need to remove the solder from this guy. Let's get a better look at it. So this is the side that was faulty, and this pin is what gives us problems. And you can see, yeah, this doesn't look good. Okay, so this chip you can acquire new and probably pre-bowled from eBay under $5. So that's not a huge thing, even if you break it during the process, as long as you don't rip any of the pods from the board. Even if you fry this chip and it doesn't work anymore, no biggie. It's available. Oh, it dissipates heat very fast. So you need a big tip for this. Okay, that looks a lot better. Oh, now let's clean it, because it's sticking to my tweezers, because it's drowning in flux. So let's get some alcohol. Okay. Now, first, let's put the drop of alcohol on it. Let it work its magic. Oh, come on. I probably should use different tweezers for this. Don't run away. Alrighty. Okay, doesn't look too bad, but not that great either. Okay, I'm gonna see if I can figure out the other camera, and we'll jump to the next step. Okay, the chip is not exactly clean. What is this? Second tweezers. Let's get rid of this. What's all this? Okay. Now let's switch the tip to appropriate one for this job. Now I don't need a lot of heat because I'm going to be working with leaded solder. So both the tip can be smaller and the temperature can be lower. So this is the tip. It's still pretty big, but it'll do. It'll be much easier. It's actually much easier working with bigger tip than a tiny tip and trying to get the temperature high. Let's do 270. That's more than enough. This solder melts at 183. I did let's do 260. If you set the temperature too high, then the solder is not gonna stick to the tip. If you do it too low, it's not gonna flow. Let's get some flux on the chip. It's a lot of flux. Now, the point is not to get too much solder in the center, because if you do, when you press the chip, it might create a solder bridge underneath the chip, which you can see. So, it's better that there's not enough than too much. So, let's see, the soldering iron is up to the temperature. Let's just see those little babies here. How are they going to react to all this? This is still leaded solder on those, but not a lot of it. I don't really have anything to hold the chip, so I need to kind of go around. Let's see if I get some solder on my iron. There you go. See, if the temperature is too hard, if this doesn't happen to you, right, it doesn't want to stick, that means the temperature is too high. It just runs away from the soldering iron. Bless you. Okay, and this guy here. Okay, there's a little bit of leaded solder on it now. This guy once more. There. And there. And there. Okay, so these are easy. I'm not putting any solder here because I'm going to put some on the board, and I want this little solder in the center as I can, for two reasons. One, I already mentioned, you can get solder bridges if you press the chip. Second, if you have very little solder in the center, then you don't need to press the chip. If you have too much and you don't press the chip, then these guys around will not get the good connection. But there are ways around it as well, but not as effective as just doing it this way, or at least in my experience. I might be wrong. Now let's clean it a little bit to make sure that, I don't like that one solder, that one joint over here on this side. Or is it just a light? I don't have a ring light on my microscope because it doesn't work for me. I need to have the light from on the side so I can manipulate the shadows, because I have no depth perception. So ring light doesn't work for me even if I have stereo microscope, for that reason. Okay, I didn't clean my tip and I burned myself. Just a little bit. Just a little bit burned. Okay, the tip is not so clean. Okay, now it's clean. So when you work with leaded solder, never leave solder on your iron, on your tip, because it's gonna be releasing lead into the air while it's cooling down. Not good. And as you can hear, I have no fume extractor. And a little bit shaky hands today because I've been shoveling snow. But back in the day, I thought you could not do this job when you have shaky hands. I thought, no way, there's no way to do it with shaky hands. And then I watched Louis Rossman's videos, and sure you can. He's got like really shaky hands, and he can do that. So I no longer think that you need a steady hand to do this job. Okay, the chip is ready. Now the board. Same thing. A little bit of flux. That's even a bit too much flux, but and the same thing. A little bit of solder on my iron, and you don't actually touch the pins, you touch them with the blob of solder. Oh, what's happening here? The temperature is too low. The board is taking off, is dissipating too much heat. So either I need to preheat the board or raise the temperature on my iron. Let's go 20 degrees higher, 280. Why is the image on the camera so blurry? There. Sorry about that. It was clear under the microscope. Oh. Let's try again. Okay, that's a lot better, but it's still not enough. Let's try the higher temperature first. Let's do to 9300. Looks like the board is dissipating heat too quickly, so the solder is not flowing. If that be the case, then I just raise the temperature. But either I have to put the bigger tip or preheat the board. Or maybe there's too much. Now I cleaned all the lead-free solder. This is all leaded solder. Let's try here. I up the temperature a bit again, and looks like that did the trick. Okay. And now let's work here. That is good. And I'm touching the pads, which I should not be doing, but I'm pretty confident when I'm going this way that I'm not going to rip it off. If you're going this way, never touch the pads, especially when they heat up, they just fly off, and as I said, with tiny traces like this, it's not going to be a pleasant thing. Now, oh, and you can see how quickly this dissipates heat, and that it's unleaded solder. Yeah. So now, let's see if I put a little bit of leaded. Oh, see, it's even catching my solder. It's really dissipating heat very quickly. Let's up the temperature to 340. 340, and let's see if we can do it. Clean the tip without burning yourself, which I did. I actually burned myself twice. Cleaning the tip just a few minutes ago. So that's probably some kind of record. And some more flux. Let's see. Oh, that's a lead-free solder. This does not want to flow. Let's do 370. If that doesn't work, I may need to switch the tip again and clean all the surface again, which I don't really want to do. I could also preheat it. No, this is awful. This is awful. It's not flowing. That's not going to be good. Two things. One, some lead-free solder is left there. Two, it dissipates heat because it's a big pod, and that's what it's designed to do, because this chip is supposed to dissipate some heat. Okay. This is like very close. Very close. Let's see if I can do it with the temperature alone. Let's do 400. 400. If that doesn't work, then I need to change the tip. No, alright. That's better. Not perfect. That's definitely better. There's a big blob over here. I kinda... I'm tempted to just put the wick on it, but I'm pretty sure if I put the wick with this tip, it's just gonna catch the wick, and I won't be able to take it off with this tip. And I don't want to change the tip. And the reason I don't want to change the tip is because I'm using the cheap tools So to change the tip, I need to wait for the device to cool down, change the tip, and heat it up again. It's just kind of laziness. Nothing new in my profession. Actually, my profession is software engineering, so we're just lazy by definition. I'm not sure about this one, because that means I'll have to heat it up really freaking high, and I think I'm gonna press on it as well. Well, let's see if that's gonna work. Let's put the iron to 100, and yeah, if it wasn't for that center, that would be pretty nice. I could also use, let's see, the paste. What's the melting temperature of this paste? Low temperature storage, okay, 138. So I could actually, let's try it. Actually, okay, let's get the temperature up again. Let's do 350, and let's try some soldering paste, the equivalent of low melt solder, which I don't have. Oh, you're kidding me. Come on, open. Yes, I'm just gonna use the knife and screw it. Okay. And let's get some appropriate tool for this job. This one. And okay. So when that mixes with this solder, it should lower the temperature, the melting temperature, and it should make it easier. At least that's the prevailing theory. It's running away from me. Well, it is better, that's for sure. So now, okay, that actually did the trick. It's actually working. Now let's up the temperature then. 380. Let it heat up. Oh yeah, that definitely works a lot better. I'll have to clean all those tiny bowls, but that looks a lot better. not sure if that was the shape of it before, or did I mess it up here? But that definitely did the trick. Probably need to get some low melt solder and sticks, because it's a shame to use paste for this. It's not exactly what it's designed for. Okay, I want to get this, as much of this solder off, so when I place the chip, it lays flat. And as even surface as I can make it. And this little blob, let's see if we can remove it. Oh, okay. Oh yeah, solder paste to the rescue. That's actually pretty good. Beautiful. Look how nicely it's melting now. Okay. Yeah. See, that's the well, not problem, but that's something to remember. Before you start blaming your skills, make sure you have proper equipment, proper, well, not tools, but proper chemicals you're working with. I know I spent some time trying to figure out how to solder something back in the day. I just couldn't, and I figured, no, I just suck. Why do I suck? Why does it look so easy on YouTube and I can't do it? And it turned out I had a lead-free solder. So yeah, that was the reason. Okay, that should do it. Now let's put the paste away. Clean your tools. Always clean your tools. After you're done using them, because as my father always used to say, you take care of your tools, the tools will take care of you. Otherwise, they'll stab you in the back. Okay, now let's clean it up a bit to see what we're working with. All that paste that didn't melt. It's stuck a bit. It's not good, because once I expose it to heat, the first thing that's gonna melt is that paste. So I really gotta make sure I don't have any over here, because it's very easy to make a bridge. And then, yeah, I still think I got a bit too much solder on those center pads on that, I assume, ground. Hang on, which side it's that pin, number 2, yeah, so it might be ground. I could check it. This board, I don't think it has too many layers, so you could reverse engineer it and, you know, draw a schematic for it, which would be very helpful. Or board view. Luckily this problem is not as intricate, because this is already diagnosed. These cars are notorious for having this issue. So this is actually pretty easy repair. It just takes some skill and some experience. But diagnosing the problem, that's the skill. That's what's hard, to figure out what's wrong with it, and then to fix it, that's not an issue. Okay, now dry, and that looks good to me. Let's see it under a few angles. Kind of worried about this one blob over here. This thing might be too much. My iron's still hot, so I'll see if I can get rid of it. I need to cut the wick. And let's see. Heat it up a bit. Yeah. A little bit more. Okay. Let's try a little bit more here. A bit more here. Oh, yeah. Okay. Alright, that should do it. Slow melt, so it should start melting before even the pins are gonna start melting. One more quick cleaning. Yeah. Okay, I'll douse it in flux. That'll hold the chip in place. Then I'll start heating it, and it should jump in place by itself. At least that is the theory. Now, the chip orientation. This is pin number 1. Let's get the chip, find the pin number 1 on the chip. Pin number 1 is here. Yeah, so that will be the orientation. Let's put it here. Some flux. Okay. I prefer to do too much flux than not enough. This is definitely a bit. Oh, I didn't put on a flux on that side. Here. Yeah. It only covers like half the pin, half the pad. So it doesn't need to be all the way there. Okay, so that is the orientation. And now the temperature doesn't have to be quite as high as I used to desolder the chip, because now we're using leaded solder, which is good. Because that makes it easy, or easier. Nothing's ever easy. I got 350 here now. 280, 290, but it's still pretty damn hot. Actually, maybe I'm gonna start with 270. No, what did I say? No, 280. So this one's almost over 180. I'm gonna be using 280. Yeah, let's use 280. Okay. Moment of truth. The chip is already. Oh, let's start heating it slowly and actually reduce the airflow a little bit, because I don't need it to be this high. And let's place the chip again. It will jump in its position when it's hot. Once the solder starts melting, but you see, now is the problem, because it's jumping on the. Okay, well. Because there's a little bit of solder bolts in the center, so it's not sitting right. Okay, if my airflow was higher, the chip would be dancing. And this is what we want to see. And I prefer to do it this way. And I'll inspect the joints later. And if need be, I'll add some more. Now let's see. If I touch it a little bit, it should still jump back in place. It didn't. It didn't. So is the temperature too low? Okay, jumped into place. I don't know if you've seen that on my. Oh, I see that you haven't seen that because it's a little. Yeah. Okay, so supposedly it jumped into place. The solder up top is not shiny, which is a concern. It probably wasn't heated up enough because I was blowing from the other side. Yeah, see this side over here? This side here. The solder is not shiny. The chip is firmly in place. So let's turn off hot air so I don't burn the apartment, and let's clean it. Let's see what it looks like. How hot is it? Oh, too hot. I heated that capacitor there. This one a bit too much. It's 47 volts, or is it 4.7 microfarads? That's a bit too small, or maybe it is. Anyways, I heated it a bit too much, so that was risky. That was risky because I'm not using any eye protection, and that is not fun when these guys explode on you. I had one exploded on me. Well, I was much younger back then, so it was a lot scarier back then because I didn't know they do that. but still, now I don't want to experience that either. 20 some years later. Okay. Now, since I didn't press the chip, I'm not gonna put UV mask on it, because kind of important thing with these boards, they are made waterproof. I put like some mask on it. So now I removed it to remove the chip, so it's no longer waterproof. This whole area around here, actually, because the heat takes off that thing. You can see the difference here. See all this stuff? It's across all the board, right? And that makes it waterproof. It's no longer waterproof here. So let's let it cool down. I'm gonna go clean my tools, and I'll probably bring it to the car, see if it's working, and then put the UV mask pretty much everywhere over here, like including this cap and all these, because there's some over here but not here. Yeah, that heat really destroys that mask, that factory mask. It's like some kind of glue or something, I don't know, something like that. When it gets hot, it turns into this sludge. And I'll clean all this, and that should be job done. Okay, so after a closer inspection, I see that the reason this is not shiny here, because there's not enough solder, which might cause the same issue that I had in the first place. So I'm gonna get the soldering iron to the temperature of 260, around 260. Solder. This is actually what I should have done in the first place, or should have done without even inspecting it first. After a soldering chip like that, it's best to put some flux here and put some nice leaded solder all around the chip. It'll stay, it'll not dislodge, it'll not move, because it's being held by those two big pads over here. So this should be pretty easy. Let's get some nice light, and maybe a little lower magnification. We don't need it that high. And okay, first I'm gonna do this side. So clean the tip, flux, that's a lot of flux, you don't need that much. A little bit of solder to the tip, and temperature is too low because the chip is, let's do 285. The chip is dissipating some of that temperature quickly. Too much solder. Each leg of the chip, just still too much solder on this one. Come on, get some of that solder off of there. Come on. Doesn't want to catch because the temperature of the iron is a bit too high for this to work, so let's take a little bit off. Okay. So each leg needs to be nice and shiny. There. And the same on the other side, or the rest 3 sides. And you can't really inspect it until you clean the flux. So don't even bother inspecting it beforehand, before flux is gone, because it can look deceivingly bad, and then you clean the flux and it's awesome. And the other way around, it looks good when the flux is there. You clean the flux and it turns out that there's a cold solder joint. Yep, clean the tip. Clean the tip. Too much solder on this one, but I'll inspect it after I clean it, and if it's actually too much, I'll just remove it with the wick. Now this guy, clean the tip, a little bit of solder. Oh, that's probably too much. Oh, I don't have the angle here. This one's not really. Yeah. This side is the problematic one, pin number 2, or second from the left here, or the right. And this is the side that is giving me most problems. So I think I know what the problem is with the board, or with this cold solder thing. It's probably that the board is at fault here. Because this is not supposed to be doing that. Let's see. Okay, that looks a lot better. And this side will be problematic because I don't have a clear angle to maneuver my iron. Well, let's see if I can do it. From Colorado. Probably spam call. It's best to email me because I get a lot of spam calls. Or text, WhatsApp, what have you. Not calling, not so much. There's just too much spam. Okay. This guy. Not sure about this guy, but then again, clean the board before you inspect. Now cleaning. A little bit of flux, a little bit of alcohol. There. Okay, now it looks a lot better. I'm still not sure about this side, but I have the worst angle on this side. It's kind of hard. Such is the life. Let's clean the chip. Now, yeah, I'm not sure about this side. This side looks good. And this side looks pretty good too. And this actually looks awesome, this side, because I had the best angle on this side. And the worst angle on this side. So you can tell that this side was more difficult. One more. One more. Okay. This side's good. Oh no, this one's not. One more pot. This one. This pot over here. And this one and this one. I would say those need to be touched up a bit. Okay, let's see this side. No, this one's perfect. Yeah, you can tell that I had a good angle on this one. How about this guy? Yeah. This one looks alright. And this one looks nearly perfect. It's a little bit of dirt there, so that's okay. Yeah, so this side needs to be retouched a bit. Which means I need to catch a good angle. $285. Let's reduce to 280 because I think my iron is a bit too hot. A little more flux, and let me try just these two first and see how they can work. Clean the tip. A little bit of, oh, why is my solder so dirty? Now a little bit of there. That's a lot better. And this one, of course, you're gonna bridge because there was too much solder on that one. This one, I need to take off some of it. Still a bit too much. Oh, come on. Okay. Okay, that should be alright. Oops. Yeah, that's why you should never do it while you're holding a hot iron. Put it back first, and then start maneuvering the board. Okay, let's yeah, one more. This one. Where's my tweezers? And this one here. And this is not perfect, but it'll do. I prefer there's a bit too much solder than not enough. I'm gonna put UV mask on it anyways, so I don't care even if it's too close. And flux. So, left hand operation. Okay. Come on, baby, come on. There, that's better. Okay, clean the tip. Alcohol. Let's actually reduce the magnification. There. And let's inspect it again. The key is not to rush it, because if you rush it, you're gonna have to do it again. Better to do it well the first time than to redo it twice or 3 times because you were rushing. Not in this profession. Not in this profession. Okay, and the inspection. Let's see. It's a little bit wet, but I can see it just fine. Yeah, 1, 2, 3, 4, 5, 6, 7. All good. All good. Okay. Okay. So the chip is soldered on. There's no way we're gonna have a cold solder on this pin anymore, because I put the most effort in that one, because that was the travel one. This one I believe is NC, because it could be done better, but I believe this is NC, and this one. Because I didn't see anything connected to it and no through holes, so I'm pretty sure we're good there. Now let's throw it in the ultrasonic cleaner, clean it up, put some UV on it, and the job is done. Okay, so the chip is soldered back on. Oops, come on. It doesn't look too pretty yet. Next step will be to put a UV mask on it, which I have here somewhere. It's a black UV mask. I'll put it all around the chip and the surrounding area, because the seal that originally comes with it had to be removed for the soldering. The whole operation takes about half an hour to an hour depending on the skill. It's actually a pretty easy job. I'm gonna go test it before I put the solder mask. The only thing that you need to be worried about is that electrolytic capacitor next to it. That's why I put the Captain tape on it, because they do explode if you expose them to too much heat. The chip can be, if you manage to destroy this chip, the chip can be acquired on eBay or AliExpress and all those for about $3 to $5. So it's not a huge loss, as long as you don't rip the pads off of the board. If you do, send it over to me. I'll restore the pads and fix the chip. Otherwise, if you have the same problem with your Subaru, feel free to shoot me an email, send me the board, and I'll restore it for you. Other than that, the car should be running beautifully from now on. Thank you for watching, and I'll see you next time. Okay, so we have the next day. I already tested it last night, and the misfire was gone. But since we have -8 degrees today, pretty cold, let's see if it's gonna start in the morning. And remember, the misfire is not gone until it's gone for at least 2 weeks. And there you go. The misfire is gone. Now, since I disconnected the battery before taking out the computer, the error code just disappears by itself. You don't need to reset it. On the other hand, if you take out the computer without taking the battery out, and put it back in, the misfire will still be there. It's kind of a good practice to always disconnect the battery before taking out anything from electric components. All right.